Hello, everyone, and welcome to Baldwin's Unlocking Potential podcast series. I'm your host, Tyler Kern. Thanks so much for joining us for another episode of the program. Today, I simply want to introduce you to someone who has a lot of experience in the industry and recently joined Baldwin, and wanted to talk a little bit more just about his experience and what he's found and what he's learned since joining Baldwin. And so really excited to have this conversation today and to welcome Kevin Joesel on the podcast. He recently joined Baldwin, and he brings a rich history and deep knowledge of industrial UV curing to the show today. And so we wanted to lean on some of that expertise. So Kevin, welcome to the podcast. Thank you so much for joining me.
Well, thanks, Tyler. This is a new experience for me. So yeah, kind of looking forward to it.
Well, I'm excited to introduce you to the wide world of podcasting, Kevin. You're going to be a star after this episode, much sought after amongst industry podcasts. And so just prepare yourself. I'm happy to be your agent for a 15% fee. But
you're more than entitled if that happens.
Well, I am really excited to have this conversation, Kevin, and excited to dive in. But before we go too far, tell us a little bit more about yourself, what brought you to Baldwin in the first place, and your role within the company.
Yeah, well, I'll start with the role. My role is basically to bring the technology that Baldwin has, and specifically the AMS spectral UV product line, into the industrial UV curing market. AMS has been very successful and is a leader in terms of UV for the print industry. And they have some unique product attributes in several product lines. And my background that I need to bring forward into the industry because they're definitely unique. Starting at the beginning, I've spent most of my first half of my career actually selling raw materials into the paint, coatings, and inks industry. Concentration would be the automotive coatings market primarily. And as UV curing was being adopted more by automotive, I moved into the process equipment side of the business. And as much as I love chemistry, the puzzle you're trying to solve when you're doing process development and process control and the troubleshooting that's all involved is absolutely fascinating.
So you like kind of diving in and solving puzzles and that sort of thing?
Absolutely.
So what are some of the uses for LED UV curing in the industrial market that you've seen? Tell us a little bit more about some of those use cases.
Sure. I mean, actually, the first applications for UV LEDs were 20 years ago was actually curing adhesives. And that is still the case. That's a primary example. They can be potting compounds, encapsulants for electronics. It can be bonding. One of the big applications is an optically clear adhesive that's used in all of your electronic devices. So behind the screen, behind the glass, is actually an adhesive that bonds the display to the glass. And that's just a small example. There's a lot of examples where UV LEDs are in this industry. And then they started to expand into the inks. And of course, that is where Baldwin sells most of their products. But what's happened is because of the energy benefits and lower energy usage, and there's a whole lot of other ones I could talk about in the future, the industrial curing market is looking at these products. There's a few, I'm going to say issues, but a better word's challenges for the technology to be adopted further into the industrial UV curing space. And that's why I'm here. I'm here to solve those problems.
Ever the problem solver and puzzle solver, like we mentioned earlier. I love that. I love that that's what brought you here. So what do you see as some of the advantages of LED UV in these applications? What do you see as some of the primary advantages here?
Well, there's two that are are the big two. And the one is the use of less energy in terms of, power out of the wall to photons that do work. Unlike other sources, with a UV LED, all you get is UV out of the device. The competing technology are arc lamps, both low pressure and medium pressure. And those are very hot and they don't turn on and off immediately. And you get a lot of infrared radiation, you get a lot of visible light. And a lot of cooling is required. And when you start looking at LEDs, and we specifically do water cooled LEDs because that's ideal for an industrial environment. Um, you don't have the noise. It's instant on off, lower usage. It's very difficult to do a one-to-one comparison because you are kind of comparing apples to oranges here. A UV LED formulation has to be formulated to be cured by UV LEDs. So, you have to, when you try to do a comparison, you're not always going to get, you may get a tangerine compared to a cara orange kind of thing. So, yeah. And so it's the energy. And you have all these attributes of not having infrared energy, not having visible light. So constructing the whole subsystem around the lamp is a lot easier. It's a lot less complex. It runs quieter. In the next big advantage is it's instant on, it's instant off. We're talking about milliseconds. And that's really the key benefits to this technology is it makes UV curing easier to implement, less costly to implement, and less costly to run.
So Kevin, let's get technical and specific here for a second, because what you're describing really is side-fire reflection. So tell me a little bit more about what that is, what that means, and what this process entails.
Yeah, I mean that's the unique technical aspect of this product. In the housing, there is a parabolic reflector. So what we're doing is we're taking LEDs, we're shooting into this reflector, and then this reflector is bouncing it down through what's called the aperture, through a piece of glass, and that's what's coming out of the lamp. It's kind of a beam. As you measure it, it becomes a peak of a curve, but that's kind of how it looks. And what this means is we've been able to go further away with very little loss of intensity. Even if I'm 2 inches away, I'm still within 65, 70% of the peak intensity. So that is the secret sauce, so to speak, in this product. And I tend to call it a side fire because almost all LEDs sit above the product and the product runs underneath it. And we're going 90 degrees and doing this reflective technique. And it's this reflective technique that provides all the benefits.
So, Kevin, I heard you mention a lot about side fire and how the intensity doesn't rise and fall with distance, right? Am I describing that right? So, are there any other examples of where this can be beneficial?
Yeah, absolutely. I spent most of my career in actually setting up processes to cure three-dimensional parts. So that's about arranging lamps and arranging parts and making sure you can get as uniform of energy around that part as possible. And with conventional UV LEDs, that has just not been possible. I mean, you need to control within millimeters, and it's impossible. So when you are going to try to project energy, maybe up to 6 inches, this is it. Nobody else can project energy uniformly the way this product does. And yeah, that opens up a whole new world in the industrial space.
So how, given your experience in the industry and some of the things you've seen, how have you seen this technology develop and grow over your time in the industry? Give us a sense of where we are from where we started from.
Yeah, I mean, 20 years ago is when I first saw my first UV LED. And it was at a rad tech in Europe and actually in Basel. So the deal was they had to be water cooled because they were very inefficient. They were only getting 5% of the power that you put in coming out. So they had to be water cooled. They didn't have power and intensity. They couldn't penetrate. They just, weren't there. They just weren't viable at that time. But about 5 years later, as they improved LED manufacturing, they were able to get the power out of them, and they were able to start curing the adhesives, as I mentioned before. And the goal with LEDs is to make the LED chips more efficient, and then for a company like AMS Spectral is to integrate those chips into a solution that's superior, that's out there. So right now, we're at the point, about 10 years ago, you could say UV LEDs could cure anything that a traditional lamp could in the printing space. And it just started dominating there. And that's the biggest market segment for UV curing is actually printing. So that's done really well. But the big, huge installations are kind of in the industrial space. And what's happened is actually customers kind of found our technology and started adopting it. And the company went, "Hey, there's something going on over here. We need to exploit." And I mean that in the kindest sense of the word. And so, yeah, that's kind of where we're at in the AMS spectral UV design. Where I worked before, we had LEDs also. We had conventional lamps, just like AMS does now. But their design is absolutely unique to what else is out there in the marketplace. And when I first got with the company, I was looking at this and went, "Holy moly, they really have something. They've really got something special here."
That's really really fascinating, and I wonder just how big of a part then that you feel education can play in the marketplace, educating people on the capabilities of this technology and how far it's developed. Is that something that you think about on a regular basis? That more people need to know about the capabilities
Oh,
here?
absolutely, absolutely. AMS had this technology, and I remember seeing it, but I didn't know what the payoff was. I didn't hear the message about, "Oh, this is," all I heard was it's different. And I couldn't really understand. Now I could tell you, I started seeing, AMS get business in this area. So I was like, well, that's interesting. But I really didn't understand what it was until I got here. And that was about 6 months ago. And when I finally got my hands on the unit, started looking at it, this design is absolutely unique. It's elegant. It's yeah, I don't know what else to say. It's impressive. It's impressive, and I'm really happy I'm the guy that gets to push it.
So, so what are some of the new challenges in industrial curing applications when it comes to intensity and dose and things like that?
Yeah, right now. So, and this leads from your last question, which I didn't answer. So, yeah, the intensity levels it kept going up, and when you got the intensity levels up, where you're getting your curing, the next term everybody is concerned about is dose. And that's basically just this intensity over time. So the faster you want to run, the more dose you have to have. So, and it's directly scalable, meaning if I'm running at 100 feet a minute and I want to go to 200 feet a minute, I need twice the energy. And that means I would typically just put another lamp in sequence. So it's directly scalable. But as you move from the print industry and you move to the industrial, what you have is a big difference in the mass of the product you're trying to cure. The converting industry, for example, is like putting pressure sensitive adhesives down in creating clear tape, masking tape. You think of tape, and those are pressure sensitive adhesives. All these products that have adhesive pads that you use, on the wall, those are pressure sensitive adhesives. And they're actually used quite a bit in the industrial space, such as automotive. But what I'm talking about here is you have more chemistry to cure. And more chemistry to cure means you need more dose. And that's really what AMS spectral UV has been able to do, is they're able to deliver more dose in a more compact space. And one of the other attributes is that nobody else could do is we have the same intensity at the face of the lamp as we do 1 inch away. Nobody else can do that. We're at the same level. Almost everybody out there, if you go 1 inch away, if you don't have any what I'm going to call secondary optics, you're going to be down around 25% of your peak intensity. So any variation you have in that distance from the part or the substrate to the lamp, you're going to change your intensity levels immensely. And so that's why UV curing has been pretty much relegated to doing things in the flat, where that distance between the lamp and the product is controlled, precisely controlled. Yeah.
Right,
Yeah.
right. So where then, we've talked about, you like to solve problems and you like to chart the path forward by solving problems and fixing these issues and things like that. Where do you see things going over the next 5 to 10 years? What problems are you
Sure.
looking at solving, and where does that take the industry
Well,
next?
the thing that has to be solved to continue to expand the use, and it's more important probably in the industrial space, is we have to have UVC energy. And just to give you an idea, UVC LEDs are about the same point in time as UVA, which is what we're selling now in mass, was about 12 to 15 years ago. So they've got to go up their own technological curve, and they've just kind of looks like they've hit an inflection point. So the last article I read was kind of saying that on a commercial basis, it's probably going to be 2030 before we get to UVC. Now, that's with an LED, but I could still give you UVC with a conventional lamp. And because this is, and I haven't mentioned this before, but this is really to cure the surface, which is, LEDs have an issue. They're great at bulk cure and penetration, but they're not the best at curing the surface. You can just use a regular arc lamp and just give it a little bit of a kick in the butt, so to speak, at the end of the process.
That's really fascinating and just really interesting to learn more about. Absolutely. So, so Kevin, kind of coming back to your role at Baldwin and to what you're doing now, what was it that really blew you away when you first joined Baldwin and got to see the latest and greatest technology just up close and in action? You've kind of talked a little bit about this, but I wanted to ask specifically just what you saw and what excited you so much about what you were seeing.
Sure. I mean, first and foremost, it's the product and the advance in the technology that they have, but right behind that is we make products, sell products, and the thing you have to have the capability to do is service products. And what you see is a lot of people coming in from overseas trying to get into the market. Companies that are very well known, very good, say over in Europe, but they don't really have a technical service presence here in the United States. And AMS spectral UV is absolutely global. We have tech service people in all these locations around the world. So for my perspective as being a sales oriented person, I could get the first order and do a lot of work, but if you want the second order, it's all those other people behind you that really get the second order for you. And AMS Spectral and Baldwin Technology absolutely has that.
When you have these conversations with customers and potential customers, what sorts of questions do they have about Baldwin and what you're capable of? And what are they looking to find and to learn and to know about your products?
Right. They've literally been looking for a technological leader in this LED space into the market. They want to go, but I don't think they've been getting the best help because the dynamic in the industry has changed due to LEDs. I mean, LEDs have made it easier to use. LEDs have made it less expensive to use. But what goes along with that is that people are asking the customer to do process development, to do process control, and they really don't have the people in the organization to teach it. You brought up about education. Education is absolutely paramount. And that was one of the first things AMS was surprised with when I started asking, where's your presentations on this? Where's your presentations on that? And they're like going, well, we don't need it for we haven't needed those. And it's like, yeah, that's the problem with the industrial market is you spend a lot of time educating potential customers about what the technology is and how it can be used.
So, Kevin, as we start to wrap up this episode here today, it's been fascinating, and I've loved getting a chance to learn more from you and learn more just from your experience that you have in the industry. What do you hope people walk away with from this conversation? What do you want people to know after they've listened to or watched this episode?
Sure. Call me. That's what I want. Call me. Be more than happy to provide what you need. And if that means a quotation, if that means education, if that means an explanation of the benefits, what the features and the benefits are of the technology and what we're offering and why it's such a superior solution, I'm more than happy to talk to you.
Great stuff. Best way for people to get in touch with you? Should they go to the website? Should they visit you on LinkedIn?
Sure.
Any preferred method?
I'm pretty active on LinkedIn. LinkedIn's always a great solution. My cell phone number is 240-778-4936. And, it's kevin.joesel at amsspectraluv.com. So.
That's Joesel, Joesel.
Thank you.
Joesel.
Thank you for
Kevin
that.
Joesel. There you go. And you can always visit the Baldwin Technology website as well. That's baldwintech.com. But look, Kevin was brave enough to give out his cell phone number on the podcast. So look, if you have questions, if you want to learn more, if you just want to chat a little bit more about LED UV curing, give Kevin a call and learn more and learn from his experience. Kevin, it's been a pleasure having you on the podcast today.
Same here, Tyler.
joining me.
I appreciate it. Thank you.
Absolutely. Everyone out there, remember the website is baldwintech.com if you'd like to learn more. And of course, we've got previous episodes of the podcast. If you want to go back and check out some of our other episodes of the show, you can do so on the website. You can use Apple Podcasts, Spotify, wherever you get your podcasts these days. You can go check out the Unlocking Potential podcast series from Baldwin and check out more there, of course. And stay tuned. We'll be back soon with more episodes of the show. But for this one, for Kevin Joesel, I'm Tyler Kern. We'll talk to you next time.